To check the harmonics of a generator backup system with a reasonably priced USB oscilloscope for single-family dwelling with 120/240 volts one-phase power, several options are available. Firstly, the Rigol D1054Z is a 4-channel oscilloscope with a 50 MHz bandwidth and a 1 GSA/S sample rate. It features a built-in harmonic analysis function and USB connectivity. Its price is around $500. Secondly, the GW Instax GD-1202B is a 2-channel oscilloscope with a 200 MHz bandwidth and a 1 GSA/S sample rate. It offers FFT and harmonic analysis functions as well as USB connectivity. Its price is around $400. Thirdly, the Siglent SDS1202XE is a 2-channel oscilloscope with a 200 MHz bandwidth and a 1 GSA/S sample rate. It features enhanced FFT and harmonic analysis capabilities and USB connectivity. Its price is around $600. Fourthly, the Hantek DS-10102P is a 2-channel oscilloscope with a 100 MHz bandwidth and a 1 GSA/S sample rate. It includes FFT and harmonic analysis functions along with USB connectivity. Its price is around $300. Fifthly, the PeakTech 5166 is a 2-channel oscilloscope with a 100 MHz bandwidth and a 500 MSA/S sample rate. It offers FFT and harmonic analysis functions and USB connectivity. Its price is around $250. When selecting an oscilloscope for harmonic analysis, consider several tips. Firstly, consider the bandwidth required to capture the harmonics of the generator. Typically 100 MHz or higher is recommended. Secondly, ensure the oscilloscope has a high enough sample rate to capture the details of the harmonics. Thirdly, look for oscilloscopes with built-in harmonic analysis functions to simplify the analysis process. Fourthly, choose an oscilloscope with USB connectivity to easily transfer data to a laptop for further analysis. Fifthly, consider the price range and budget before making a purchase. A higher bandwidth allows the oscilloscope to accurately capture faster changing signals, which is crucial for analyzing high-frequency harmonics. A sufficient sample rate ensures that the oscilloscope captures enough data points to accurately represent the waveform, preventing aliasing and ensuring accurate harmonic analysis. Built-in harmonic analysis functions can automate the process of identifying and measuring the amplitudes of different harmonics, saving time and effort. USB connectivity allows for easy transfer of data to a computer for further analysis and reporting. To elaborate on the technical aspects, understanding harmonics is essential. Harmonics are integer multiples of the fundamental frequency of a waveform. For a 60 Hz system, the second harmonic is 120 Hz, the third harmonic is 180 Hz, and so on. These harmonics can distort the original waveform and cause various problems in electrical systems, such as overheating, equipment malfunction, and reduced power quality. An oscilloscope is used to visualize and analyze these waveforms. The bandwidth of an oscilloscope determines the range of frequencies it can accurately measure. For harmonic analysis, it is important to have a bandwidth that is at least several times higher than the highest harmonic of interest. A bandwidth of 100 MHz or higher is generally recommended for analyzing harmonics in the 60 Hz system. The sample rate of an oscilloscope determines how many data points it captures per second. A higher sample rate results in a more accurate representation of the waveform. A sample rate of at least 1 GSA/S is recommended for harmonic analysis. Fast Fourier transform, or FFT, is a mathematical algorithm that converts a time domain signal into a frequency domain representation. This allows the oscilloscope to display the frequency components of the waveform, including the harmonics. Oscilloscopes with built-in FFT functionality can simplify the process of harmonic analysis. When using an oscilloscope for harmonic analysis, connect the oscilloscope probe to the circuit being measured. Ensure that the probe is properly grounded to avoid noise and interference. Set the oscilloscope to the appropriate voltage and timescales. Use the FFT function to display the frequency spectrum of the waveform. Identify the harmonics and measure their amplitudes. Compare the amplitudes of the harmonics to the fundamental frequency to determine the total harmonic distortion, or THD. The total harmonic distortion is a measure of the amount of harmonic content in a waveform. It is defined as the ratio of the root mean square, or RMS value of the harmonics to the RMS value of the fundamental frequency. A lower THD indicates a cleaner waveform with less harmonic distortion. Several factors can contribute to harmonics in electrical systems. Nonlinear loads, such as electronic devices with switching power supplies, are a major source of harmonics. These devices draw current in short, non-sinusoidal pulses, which generate harmonics. Other sources of harmonics include transformers, generators, and arc furnaces. Harmonics can cause a variety of problems in electrical systems. They can increase the current flowing through the system, leading to overheating of conductors and equipment. Harmonics can also cause voltage distortion, which can affect the performance of sensitive electronic equipment. In addition, harmonics can interfere with communication systems and cause metering errors. To mitigate the effects of harmonics, several techniques can be used. Harmonic filters can be installed to block the flow of harmonic currents. These filters are typically tuned to specific harmonic frequencies. Another technique is to use power factor correction equipment to reduce the amount of reactive power in the system. This can help to reduce the amount of harmonic current flowing through the system. Proper grounding and shielding can also help to reduce the effects of harmonics. These techniques can help to prevent noise and interference from affecting sensitive equipment. In addition to the oscilloscopes mentioned earlier, there are other options available on the market. Tektronix and Keysight are two well-known manufacturers of high-quality oscilloscopes. However, their products tend to be more expensive than the Rigol, GW Instec, Siglent Handtech, and Peak-Tech models. When choosing an oscilloscope, it is important to consider the specific requirements of the application. For basic harmonic analysis, a 2-channel oscilloscope with a 100 MHz bandwidth and a 1 GSA/S sample rate may be sufficient. However, for more complex analysis, a 4-channel oscilloscope with a higher bandwidth and sample rate may be required. It is also important to consider the software and analysis tools that are included with the oscilloscope. Some oscilloscopes come with built-in software that can automatically calculate THD and other harmonic parameters. This can save time and effort during the analysis process. In conclusion, selecting the right oscilloscope for harmonic analysis requires careful consideration of several factors, including bandwidth, sample rate, analysis functions, connectivity, and price. By considering these factors, it is possible to choose an oscilloscope that meets the specific needs of the application and provides accurate and reliable results. Remember to prioritize adequate bandwidth to capture the necessary harmonics. Ensure a sufficient sample rate for accurate waveform representation. Look for built-in harmonic analysis features to simplify the process. Opt for USB connectivity for convenient data transfer. And consider the budget to find the best value within the desired price range. When using an oscilloscope for harmonic analysis, it is important to follow proper safety procedures. Always wear appropriate personal protective equipment, such as safety glasses and gloves. Ensure that the circuit being measured is properly de-energized before making any connections. Use properly insulated probes and test leads. Never touch any exposed metal parts of the circuit while it is energized. Be aware of the potential hazards of working with electricity and take precautions to avoid electric shock. If you are not familiar with electrical safety procedures, consult with a qualified electrician. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified engineer or electrician before working on electrical systems. The specific requirements for harmonic analysis may vary depending on the application and local regulations. It is important to comply with all applicable codes and standards. By following these guidelines, it is possible to safely and effectively use an oscilloscope for harmonic analysis. This can help to identify and mitigate the effects of harmonics in electrical systems, improving power quality and equipment performance. In addition to the technical aspects of harmonic analysis, it is also important to consider the economic implications. Harmonics can increase energy consumption, reduce equipment lifespan, and cause downtime. By addressing harmonic issues, it is possible to improve energy efficiency, extend equipment lifespan, and reduce downtime costs. A comprehensive harmonic analysis can help to identify the sources of harmonics, quantify their impact, and develop effective mitigation strategies. This can lead to significant cost savings and improved overall system performance. When conducting a harmonic analysis, it is important to use calibrated equipment and follow established procedures. This will ensure that the results are accurate and reliable. It is also important to document the analysis process and findings. This will provide a record of the harmonic levels and any mitigation measures that were taken. This documentation can be useful for future reference and for demonstrating compliance with regulations. Finally, remember that harmonic analysis is an ongoing process. Harmonic levels can change over time due to changes in the load or the system configuration. It is important to periodically reanalyze the system to ensure that harmonic levels remain within acceptable limits. By following these guidelines, it is possible to effectively manage harmonics and maintain a healthy electrical system. Regular monitoring and analysis can help to identify potential problems early on and prevent costly equipment failures. This proactive approach can lead to improved power quality, increased energy efficiency, and reduced operating costs. In summary, harmonic analysis is a critical aspect of power quality management. By understanding the causes and effects of harmonics, and by using the appropriate tools and techniques, it is possible to mitigate their impact and ensure the reliable and efficient operation of electrical systems. Oscilloscopes are essential tools for visualizing and analyzing waveforms, including harmonics. By choosing the right oscilloscope and following proper procedures, it is possible to gain valuable insights into the harmonic content of electrical systems. This knowledge can be used to improve power quality, reduce energy consumption, and extend equipment lifespan. Regular monitoring and analysis are key to maintaining a healthy electrical system and preventing costly equipment failures. Therefore, invest in a suitable USB oscilloscope and prioritize safety during harmonic analysis to ensure accurate results and efficient system performance.